Hello, here's lecture number 3 for computer programming A and B. Today's topics will review the time class, talk about incremental development, go over modifiers versus pure functions, talk about planned development, and end with methods, which computer programming A will need for their Pong Part 2 assignment. So for the time class, we'll be working with this in the next series, or this week, for the lectures. And time is going to help us record the time of day. It works just as we think it does. As you expect, it has an hour, a minute, and a time attribute or field. So on the left, this is how we represent it in Python. On the right, this is how we represent it in JavaScript. Notice it's very similar in its syntax. For the class keyword in JavaScript, remember there's no parentheses here. That's a common mistake that I make. In JavaScript, you also require the new keyword when creating new objects. So for your first exercise, try to write a function that prints out time. And what it does is it takes in a time object and prints it in the form hours, minutes, and seconds with colons in between them. So for Python, this is using prettyprint, so %.2d prints an integer with at least 2 digits. Even if it has a single digit, it puts a leading 0 there, so that's going to be really useful. You can pause and think about what that function will look like. Here's the answer. For Python, here's the print time using the %period 2d followed by colons 3 times. They work like placeholders. And then you put in those values, hour, minute, and time. There's your time object t, being passed in as first argument. In JavaScript, it's a little bit more simple. It's a console.log, putting those numbers together with the plus sign and some colons in between. So for this next exercise, we're just gonna go over it. It's writing a comparison function, or a Boolean function that returns true or false, called isAfter. And it takes in 2 time objects, t1 and t2. It returns true if t1 follows t2 chronologically and false otherwise. So if you had 1 p.m. for time 2 and 11 a.m. for time 2, it will return true. This is pretty neat in Python. You can do a tuple here, and tuple-tuple comparison. Let's see, in JavaScript, I'm not so sure that you can do this line, and I think I forgot to fix this slide. You can think about having this as a bunch of if statements. It would be probably if hour is greater than t2.hour, return true, and then t1, or minutes, and then seconds. You gotta check the hours first, then minutes, then seconds. So for the JavaScript class, you may want to write out this function given 2 time objects. It's simple enough. Now for add time, I forgot to mention this last lecture, we're going to add 2 time objects together. So here's our start time, 9:45, or 9 hours 45 seconds. We're going to try to increase that by 1 hour and 35 minutes. And then we should get a total time of 11 hours and 20 minutes after our add time function is done. You can think about how this would be written. pause the video, maybe open up a Replit or a CodePen and try coding it yourself before I review it. One common mistake here is getting the time 1080, so 10 hours and 80 minutes, which should be bumped up to 11 hours and 20 minutes. So we're going to address write a function for add time two ways. The first way is called incremental development, where we start with what we know, a simple version of the program, run some test cases, and then add on to our code. And keep doing that till we get a solution that addresses all of the cases. So you're breaking down a problem bit by bit. It's how we've been programming in computer programming A, where we started with a simple picture and kept adding on things until it looked right. We're calling that incremental development, or prototype and patch. So here, we started with the function add time. There's your two time objects. We create a new time object. Here's how it looks like in JavaScript. And the rest of the lines are very similar between the two languages. You add up your hours, add up your minutes, add up your seconds, and you return the sum, the total of those times. And it's this part, the first line up here, and this last line of the return, that makes this particular function a pure function, because it doesn't modify any of the objects passed to its arguments. It doesn't have any effects, and an example of effect would be displaying a value or getting user input. It only returns a value. That's all it does. But we notice with this current code that we have that adds together your hours, minutes, and seconds, this is where it runs into our first mistake. We get 10 hours and 80 minutes. That's not what we wanted. So far in our incremental development, our add time function doesn't deal with the case where your minutes or your seconds grow more than 60. You have to carry those over. So if you have 61 seconds, it's actually a minute and a second. If you have 80 minutes, that's an hour and 20 minutes. So our program needs to account for this. Here's one way to go about accounting for it. Down here, you still do the same addition, and now you'll check. If your seconds is greater than 60, take away 60 of those seconds, add to the minutes. Same idea with minutes and hours. If your minutes is greater than 60, take away the 60, add on to your hour. And then it addresses, then we get 11 hours and 20 minutes, no seconds. Here's the other way of development, where we have modifiers. So this one does have some effect. It modifies the objects that it's given. So this is a non-pure way of writing functions. And the changes are going to be visible to the users. So here is the increment function that it advances time. So here's the example. You start with a time, let's say 9 hours and 35 minutes, advance it by set number of seconds. You add on the seconds, and then do that rounding that was mentioned from before. Yep, there's your time object, there's your seconds, here's your rounding. Think for a moment, pause the video, answer these two questions. Is this time function correct? What happens when seconds is much greater than 60? Like 3,600 seconds. That's equivalent to an hour. What happens then? So one thing here that you'll notice is that with this example, it only does the rounding once with these if statements. So then, when you replace them with while statements, this repeats until it can no longer happen. Same thing with here. So if you go way over, it'll keep taking off 60 and keep adding to the minutes until we're good. But there's a way to write this without loops, and you can pause and think about how that would look like. Here's one way. Still with that modifiers idea, you're changing the objects that you're passed, you're modifying the time object here without the use of loops. So it uses integer division, it uses mod, and in Python, div mod does these two things, but all in one line. And in JavaScript, they have similar operations. Integer division, and this is the mod sign that's shared amongst lots of programming languages. So you look at the remainders and the, what's it called, quotients. Anything that can be done with modifiers can be done with pure functions. So here's a side-by-side comparison. The add time is a pure function. It creates a new object and returns that object. It doesn't modify any of its given parameters, given arguments. The increment function is a modifier because it changes the time object. It adds on these seconds, and your original object or state has been changed through the use of this function. And also it doesn't return anything down here, whereas this one does. Now, the difference between modifiers and pure functions is that we're likely going to be in this camp for modifiers. It's convenient, it tends to be more error prone, and it tends to be more efficient. Pure functions, although it's faster to develop, tends to be less efficient and less error prone, but generally it takes more time. And most computer science programs teach it in this way. They use modifiers. Pure functions, or more popularly functional programming, is less common. And this is something I found later in my CS training, but functional programming is really fun, and I wish I got to spend more time here in this camp versus mostly here. So that was incremental development and modifiers versus pure functions. Although we want you to think in like pure functions, the modifier idea is the one that we'll be ending on today. This is more familiar, this is kind of like new and wacky. The next way of development, the big brain method of development, or the planned development, right, in comparison to incremental development, is where you think about your problem for a really long time, you do your homework to achieve maximum efficiency. And we'll walk through this example for the time class, thinking about how we would add things and increment things. Here's another way to write those functions. The key observation from the time class was being that it's a number. We can think about it like a number, and it's base 60. And here's a fun word for you to Google. This is what it formally means to be base 60. So the seconds attribute is the ones column, that's on the right hand side. The minutes attribute is the 60s column, and the hour attribute is 3600 column, or 60 squared. So the add time and the increment functions, you're doing addition in base 60. And this will take care of the carrying that happens. And we're going to convert our time objects into these integers. We're going to change them all to base 60 numbers, add them, and then because the computer is really good at doing integer arithmetic, it already knows how to do that. And then we'll turn it back. So making use of this observation, here's the same or a similar example from before. You have 9 hours, 45 minutes, 31 seconds, and we're trying to add on an hour, 35 minutes, and 30 seconds. So there's two examples of carrying. Your our new way of development, making use of this revelation, is that you turn 9 hours, 45 minutes, 31 seconds into all seconds. You do the same with the 1 hour, 35 minutes, and 30 seconds here. This is how you do conversions from one base to another, base 10 to base 60. And we get a total of 40,861 seconds. And now we work backwards, starting with the seconds. You total mod 60 to get the number of seconds. You take away you think about the leftover seconds, do integer division there, mod 60. That is the total number of minutes. Your no leftover seconds divided by 3600, which is 60 squared, that figures out your number of hours. And if you read it in reverse, that's 11 hours, 20 minutes, and then 1 second. So all I did different in this example was I added on another example of carrying with 31 seconds and 30 seconds. So that's the main change. In code, this is what those functions look like. So here you start with a time, turn it into a number, like that. So that's this first part over here. This is how we get our 40,861. We would use this function. And then the second half is, given that number of seconds, there's all your division, modulus that happens. That's the second half of my slide over here. We turn it back. And that's what this function demonstrates. Some neat Python, div mod, as you've seen earlier. It does division, integer division here on this number, and then modulus it by this one. Sorry, said that wrong. This is your number that you're dividing by 60, that goes into here. This is your number mod 60, that goes into here. So the integer division is the first argument of the tuple. The next one is the remainder, so your quotient and your remainder. For JavaScript, you'll have to do this by hand. Remember, use math.floor to get the integer division part, use the percent sign to do the modulus part. And so putting all this together, now that we have the time to int and int to time functions, our add time is really simple. It's just 2 lines of code. Turn them into numbers, add them together, and then turn them back. So in this way, once you've done your homework, you put in the effort, it's a lot easier to read, a lot easier to debug, a lot more reliable. And you can extend it even. So once you have this base, you can subtract time with ease, you can multiply time with ease. And ironically, we made the problem harder here to make the solution a lot easier to approach. And although in the slide it was suggested to you, you would probably come up with the modifier solution or incremental development solution first, and then somewhere along the ways refine it, and then eventually get here, if you have the time to do that. So as an exercise, you may want to think about this case, writing the multiply time function where you take in a time object and some kind of number, and you're going to multiply that original time by that number. And some more stuff for you to try out. Short exercises. You can read here about the built-in datetime module, see how it's different than this time object we've created. And here's the last idea I want to give you. So far, what we've done with increment and add time, that's not really object-oriented programming. In object-oriented programming languages, here are the things that make them special. They have classes and methods. We've seen classes. Here's the next idea, methods. that we're going to talk about. The computations is expressed in objects. We haven't been really doing that. We've been making objects and passing them into functions. We haven't been using like every single case object this, object that. This idea is less so. Objects model things in the real world, and specifically the methods correspond to ways things interact in the real world. So here, the next couple slides, we're going to transform the functions we made into methods. And we're going to make those relationships explicit. So as a reminder, we made the time class, we made the point class, we made the rectangle class. And those three objects match how we think about them in the real world. Now we're going to add on and make them into methods. So if we look back at the slides 39 through 59, it's not as obvious the connection between the classes and the functions. For example, add time or increment, like we could increment a point, maybe it moves it in the x-axis, or we can increment time. That relationship there on whose increment it is or what does it do isn't clear. So that's why we have methods. And methods are functions associated with a particular class. They belong to specific classes. Computer programming A, like for example in your ball class, it has a move, it has a bounce, it has a show. And in computer programming B, we've used this before. We've used in our image processing assignment this save function that belongs to the process imaging library. And all these list functions belong to the list class. For the turtle class, we've used forward, left turn, and speed. So these are examples of methods because they all belong to these specific objects. So as we define these methods, the change is not that much. It's largely mechanical. We're making those relationships obvious. And we're going to go over the syntax of using those methods. So although there's a lot of text, the first one just reminds you of what print times looks like and how it works. Down here is the stuff you need to pay attention to. Previously we had them separated on their own new lines. Now we're going to put them in, like indent them and put the functions inside the class. That's the main change. In JavaScript, it's similar. You drop off the function keyword and then you add the this keyword, which we'll get to. And that's how we'll make these previous functions into methods. This thing, yeah. So notice over here how we use these functions now that they're methods of the time class. Start.printtime. Here's the dot notation again. Start is the name of the object. Print time is the name of the function. And you'll see these words come up a lot. Start is the object the method is invoked on. Invoked is a fancy word for used, or ask this function to like perform your desired lines of code. And the idea here is that previously this was called time, like here, right? Time, 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 time. By convention, in Python, we replace that first argument with the word self. Self, 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 self. It's very similar to what happens in JavaScript, where this refers to this specific time object. Self refers to yourself, or this specific time object. And that idea, that convention, is making use of this implicit metaphor, where if you were to pass this in as an argument, it's kind of like passive voice. The function is the active agent. So the first way that we had, if we passed in like a time object named start, we go, hey, print time, the function, here's an object for you to print. But in object-oriented programming, we want the objects to be first, we want them to be the active agents. So using the method would look like this: start.printtime, which in English would be like, hey start, the object, please print yourself. Although the benefits are not obvious, as with a lot of things in object-oriented programming, when we shift the responsibility from the functions to the objects, it's possible to do these things. Write more versatile functions, maintain code, and reuse code. So here are more examples of methods. Notice the indentation. Okay, you put it into the time class. Into time, it doesn't really have to deal with, doesn't need to belong to time objects because there's no object to modify. Lastly, there's increment. You have self, you have seconds. This is where it looks a little different because of this first argument, self. So previously, the self word wasn't there. It just looked like increment seconds. And this is how it works. You have some start time, increment it by 1,337 seconds. So this is the weird part where the left-hand side of the dot, that's self. That's your first parameter. It gets assigned here. And then your seconds, that's 1337. When you have this new argument of self, it can throw you off. So here is a typical error where it says if 3 were given, but you only see 2 arguments here. That's because your start counts as the first argument. There's 1, 2, 3 arguments, 3 inputs. And the last example is after. Notice that's the function that compares 2 times to see if the first one is after the other. When we use self and you have some other kind of object to compare, it's another convention that you call it other. It's not the current class you're in. So it looks like this. Right? We're just replacing words and calling them by other names. And to use it, it's kind of nice. This is like the payoff from all that. End is after start. It reads like English. End is after start, which is true. You had some time that was afterwards. For Thursday, we'll talk about the init method. That's in Python, the constructor. We'll talk about the string method and talk about overloading this method so it's easier to print things. And later we'll talk about some other key object-oriented ideas.